Okay, here is another lesson on factoring, and you're really not learning anything too new in this. We are just practicing all the different kinds. So the first lesson, we just did this first rule of factoring. Look for the GCF and 4 terms. And then the next lesson we did 2 terms and 3 terms. And so today's lesson does all of it. And we're also going to see a few more problems that have a GCF and then can move on to 2 terms, 3 terms, or 4 terms. Okay, now one thing I did want to add today to our chart is when we do rooftop, remember I like to call it A times C rooftop. And now I've got the easy one. That's when the A's a 1. And then I have to do the one where we have to drop, replace, drop. Okay, so let's just start. All right, looking at this first example. So first, you're always supposed to look for a GCF. Do you think that it has one? Sorry, I'm trying to make this not blurry here. Okay, it does not have a GCF. So count the terms. 1, 2. So every time it has 2 terms, you want to see if it's this thing called a difference of squares. So let's look. Is it? Yep, it's got a minus sign, and these are both perfect squares. So we build our 2 sets of parentheses. One always has a plus, and one always has a minus. And then I take the square roots. The square root of 9x squared is 3x. And the square root of 25 is 5. And that's my answer. The difference of square problems, they're the easiest to do, quite honestly. They're the easy ones because there's not much to do, and you're done in seconds. All right, looking at example 2. First, we always have to look for a GCF. Does number 2 have a GCF? No, there's nothing that can divide into 16 and 81. And they don't both have n's, they don't both have y's. Okay, so there's 2 terms, 1, 2. So once again, we're checking to see if it is a difference of squares. So let's look. Does it have a minus sign? Yep. Are these both perfect squares? They are. So we're going to build our 2 sets of parentheses. One gets a plus, and one gets a minus. And then you're going to take the square roots. What's the square root of 16n squared? 4n, because 4n times 4n makes 16n squared. And then what's the square root of 81y squared? 9y, because 9y times 9y makes 81y squared. And that's our answer. Okay, next one up. First, I look for a GCF to the whole thing. I look to see if there's something that can divide into 10, 14, 15, and 21. And there's not. And they don't all 4 have x's, they don't all 4 have y's. Okay, so I count the terms. 1, 2, 3, 4. So when it's 4 terms, I go straight into factor by grouping. So this is when I group together my first 2 terms and take their GCF out. Okay, do you know what the GCF is to the front 2 terms? 2x. 2 is the greatest number that can divide into 10 and 14, and they both have 1x. Okay, let's build our parentheses and get these 2 terms back. So 2 times 5 would make the 10. The x's are a match, but I need a y. Okay, 2 times 7 would make the 14, and the x's are a match, so I don't need any. Okay, so now I'm going to group together the back 2, but instead of taking their GCF out right at the beginning, I cheat. So remember, whatever you write here, you write here. Then I backtrack and figure out the GCF. What times 5y could make a 15y? A positive 3. And then just make sure that 3 times 7 gives you the 21. And it does. Okay, so I'm going to build my 2 sets of parentheses. Remember, whatever you write here and here, you write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes here. So 2x plus 3. And that's your answer. Okay? All right. Looking at example 4. So first, you're always supposed to look to see if there is a GCF. Is there a GCF to number 4? Anything that can divide into 9 and 36? A 9 can. That's the greatest common factor in 9. Now, they don't both have x's, so it's just a 9. Okay, remember, every time there's a GCF, build one set of parentheses. Now let's put in here what would give this back. So 9 times what is 9x squared? X squared. 9 times what is negative 36? And negative 4. Okay, so every problem today that we take a GCF out on, we're going to cover it up and see if we can factor what's in the parentheses. Just pretend that this is the original problem. So first I look for a GCF. No GCF. Then there's two terms, 1, 2. So I look to see, is this a difference of squares? It is. So we build our two sets of parentheses. One gets a plus, one gets a minus, and then I take the square roots. The square root of x squared is x, and the square root of 4 is 2. And then the GCF that you took out at the very beginning, shoo, drop it. And that's your answer. Now, if you'll notice, number 5 looks just like number 4. And it's not a typo on my part. I did it on purpose. So if I typically ask students to do this without my help, this is what they do. They realize, oh, this is a difference of squares. I've got a minus. 9 and 36 are perfect squares, even exponent. So they go straight to the two sets of parentheses, one with the plus, one with the minus. They take the square root of 9x squared, which is 3x, and they put 3x here and here. They take the square root of 36, which is 6, and they put 6 here and here, and they think that that's their answer. So it is actually a difference of squares. The problem is there is also a common factor that never got taken out. So see how this answer doesn't match mine? So I want to show you how if you don't take the GCF out at the beginning, you can fix it in the end if you spot it. So here's the thing. You can't ever have a GCF in your parentheses. If you do, you need to get it out of there. So what's the greatest number that can go into 3 and 6? 3. Okay, so let's take the 3 out now. Okay, so 3 times what gives you 3x? X. 3 times what gives you 6? 2. So 3 times x is 3x, 3 times 2 is 6. So this means the same thing as this. Okay, now what's your GCF out of these? A 3. So let's take it out. Build your parentheses. 3 times what is 3x? X. And 3 times what is negative 6? Negative 2. So 3 times x is 3x. 3 times negative 2 is negative 6. Okay, so then I just need to do one more thing to make this look like this. See how they're all smushed together? That means you're multiplying. So let's go ahead and multiply the 3 and the 3. So 3 times 3 is 9. And then I recopy the x plus 2. And I recopy the x minus 2. And now do you see? It looks the same? Okay, so I always try to look for the GCF first and take it out at the beginning. But sometimes, and I do it too, sometimes you're human and you make mistakes and you don't realize there's a GCF. And so just be on the lookout. When you think you're done, look at what's in parentheses, and if there's a GCF in your parentheses, then just get it out at that point. So that's how you can take the GCF out at the end. Okay, looking at example 6. What do you think? There's a GCF. What is it? A 3. 3 can divide into 3 and 27. Okay, let's build our parentheses, and let's get both of those back. So 3 times what is 3a squared? A squared. 3 times what is negative 27? Negative 9. Okay, now let's cover up our GCF and see if we can factor what's in here. First, I look for a GCF. There's not one. And then there's two terms, 1, 2. Is this a difference of squares? Yes. So we build our two sets of parentheses. One gets a plus, one gets a minus, and then we take the square roots. What's the square root of a squared? A, because a times a is a squared. What's the square root of 9? 3, because 3 times 3 is 9. And then the GCF, you just drop it down. Shoo! And that's our answer. So if there's a GCF, take it out, then factor what's in the parentheses as if it was your original problem, and then don't forget to drop the GCF at the end. Okay, number 7. First, I look to see if there's a GCF. Anything that can divide into 2, 5, and 3 besides a 1? Nope. And then count the terms. 1, 2, 3. So when there's 3 terms, we A times C rooftop. And it's either going to be the easy one or it's going to be our drop, replace, drop. So let's check. Is the A a 1? Nope. So it's not the easy one. So we are going to drop, replace, drop. All right, first let's take A times C. What is A times C? 6. And we want the numbers to multiply to make negative 5, the guy in the middle. So I'm looking for two numbers that multiply to make a positive 6 and add to make negative 5. Now, I want to write down what a lot of students think it is, but they mess up. A lot of students want to tell me it's a negative 6 and a 1, because negative 6 plus 1 makes negative 5 when you add them. But does negative 6 times positive 1 multiply to make a positive 6? Nope. So it's not those numbers. So can you tell me who they are? Negative 3, negative 2. Negative 3 times negative 2, positive 6. Negative 3 plus negative 2, negative 5. So bing, 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 bing. We have our winners. So now we're going to drop, replace, drop. So drop the 2x squared. Replace the minus 5x with these two numbers. Minus 3, don't forget is x. Minus 2, don't forget is x. And drop. Drop, replace, drop. Now that we have 4 terms, 1, 2, 3, 4, we factor by grouping. So we group together our front 2 terms and take their GCF out. What's the GCF to these guys? Just an x. That's all they both have. Okay, let's take it out. All right, so x times what is 2x squared? 2x. X times what is negative 3x? Negative 3. Okay, then I group together the back 2, but instead of taking their GCF out, I cheat. So whatever I write here, I write here. And then I backtrack and figure out the GCF. What times 2x makes a negative 2x? A negative 1. And then does negative 1 times negative 3 make my positive 3 in the back? Yes, it does. Okay, so let's build our 2 sets of parentheses. What goes in one of them? Can you tell me? 2x minus 3. Whatever you wrote here and here, you write one more time. And then can you tell me what goes in the other set? X minus 1. It's whatever is left over. The guy in the front and the guy in the middle. So x minus 1. And that's our answer. Okay, number 8. First, I look for a GCF. Is there anything that can divide into 6, 2, and 20? 2 can. Every time you have even numbers, 2 can go into them. Okay, so let's take the 2 out. Now, if they all had an x, I'd take an x out too, but they don't. Okay, so build your parentheses. 2 times what is 6x squared? 3x squared. 2 times what is 2x? 1x or just x? Okay. 2 times what is negative 20? Negative 10. All right, so remember, if you take a GCF out, cover them up, look at what's in the parentheses as if it was your original problem, and go through the chart again. Does this in here have a GCF? Nope. 1, 2, 3 terms. So we're going to A times C rooftop. And it's not the easy one. We're going to have to drop, replace, drop. So A times C. What do you get when you take 3 times negative 10? Negative 30. And you want the numbers to add to make the positive 1 that's in the middle. So I'm looking for two numbers that multiply to make negative 30 and add to make a positive 1. And remember, if you don't know, you take what you're trying to get them to multiply to be and you start making a list. And eventually you'll find it. Can anybody tell me who they are though? It's a positive 6 and a negative 5. Those multiply to make negative 30 and they add to make 1. Okay, so I'm ignoring this GCF. I'm going to cover them up and I'm going to drop, replace, drop. So drop the 3x squared. Replace the positive 1x with these two numbers. So that's a positive 6, so plus 6. Don't forget his x. That's a minus 5, so minus 5. Don't forget his x. And drop the minus 10. So dropped, replace, drop. Now that we have 4 terms, 1, 2, 3, 4, we factor by grouping. Okay, so I'm going to group together my front two terms and take their GCF out. Can you tell me what the GCF is? 3x. Okay, let's build our parentheses and get it back. 3x times what is 3x squared? 3x times x. Okay, 3x times what is 6x? 2. Okay, now I'm going to group together my back two, but instead of taking out their GCF, I cheat. Whatever I wrote in this set of parentheses, I copy over here. Now backtrack. What times x would make negative 5x? A negative 5. And then make sure that negative 5 times 2 makes negative 10. And it does. Okay, so I build my two sets of parentheses. What's going to go in one of them? X plus 2. And what's going to go in the other? 3x minus 5. Whatever's in the front and in the middle goes in the other set. 3x minus 5. And that's my answer. Okay, we're going to just jump to number 10. I'm going to skip number 9 for time purposes. Okay, looking at number 10. First, I look for a GCF. Anything that can divide into 1, 12, and 32. Nope. Okay, so then there's 3 terms. 1, 2, 3. So because there's 3 terms, I'm going to A times C rooftop. And is this the easy one or is it a drop, replace, drop? It's got a 1 in front, so it's the easy one. Okay, so A times C, 1 times 32 is 32. And you want the numbers to add to make 12. Do you know what multiplies to make 32 and adds to make 12? 8 and 4. Okay, now because it's the easy one, I can go straight to my answer. Whatever letter the problem's using goes in the front, and then you just write your numbers down. That's a positive 8. That's a positive 4. And that's my answer. Now, for anybody who wanted to drop, replace, drop, you could do it. I don't, because this is faster. Okay, example 11. First thing up, do we have a GCF? Anything that can divide into 2, 14, and 20. Yes, 2 can. 2 can go into all of those. Okay, so let's build our parentheses and get it back. 2 times what makes 2x squared? X squared. Okay, 2 times what makes 14x? 7x. 2 times what makes 20? 10. Okay, so now I'm going to cover up my GCF, and I'm going to factor what's in the parentheses like it's the original problem. So first I look to see if I have a GCF, and I don't. Then I note that there's 1, 2, 3 terms. So I'm going to A times C rooftop, and it's the easy one. Yay! So what's A times C? 10. 1 times 10 is 10. And you want the numbers to add to make 7. So do you know what multiplies to make 10 and adds to make a 7? A 5 and a 2. Because it's the easy one, I get to go straight to the answer. Whatever letter you're working with goes in the front, and the 2 numbers you found go in the back. So positive 5, put it in the back. Positive 2, put it in the back. And then don't forget to drop your GCF. Shoo! And that's our answer, and we're done. Okay, a few more. We're almost done here. So this is everything we've been working on, just put all together. So you have to know what kind of problem it is. So that's why this flow chart is so important. Okay, first thing up, always a GCF. Look for it. Does this one have a GCF? It does. What is it? 2x squared. 2 is the greatest number that can divide into 2 and 4, and the greatest amount of x's they both have is 2. Okay, let's build our parentheses. Now, what would you have to multiply with 2x squared to get 2x squared? A 1. Now, what would you have to multiply with 2x squared to get a 4x to the 6th? A 2x to the 4th. Okay, let's cover up our GCF and pretend this is the original problem. Does this in here have a GCF? Nope. So count the terms. 1, 2. So when it's 2 terms, we want to see if it's a thing called a difference of squares. Is this a difference of squares? Nope. So we're done. This is our answer. I don't write prime because I was able to do something. If I can't do anything at all, that's when you write prime. But this in here is not a difference of squares for a couple reasons. One, this is not a minus sign, and the other reason is 2 is not a perfect square. Okay, let's look at 13. So first rule, GCF. Does this one have a GCF? It does. What is it? 6x cubed. 6 is the greatest number that can divide into 18 and 24, and 3 x's is the greatest amount that they both have. Okay, build our parentheses, and let's get it back. 6x cubed times what is 18x to the 5th? 3x squared. Because 6 times 3 is 18. 3 x's and 2 more makes 5. Okay, 6x cubed times what makes a negative 24x cubed? A negative 4. Okay, cover your GCF up. Cover your GCF up. Choop. Does this in here have a GCF? Nope, it's 2 terms. 1, 2. So let's look. We're looking to see if it's a difference of squares. Is this a difference of squares? It's not. It's got a minus, so it's a difference of, That's a perfect square. This is a perfect square, but 3 is not a perfect square. So this is our answer. This is all we can do. Okay, and one more. First, I look for a GCF to the whole problem, but there's nothing that can go into 2, 1, 10, and 5 besides a 1, and they don't all have x's. So there's 1, 2, 3, 4 terms, so we factored by grouping. So group together your front 2 and take their GCF out. Do you know what the GCF is to those front 2 terms? X squared. They both have 2 x's. Okay, build your parentheses and get it back. X squared times what is 2x cubed? 2x. X squared times what makes a negative x squared? A negative 1. Okay, in the back. I can take the GCF out, or I can cheat. Let's cheat. Whatever you write here, you copy here. Now backtrack and figure out the GCF. What times 2x makes a negative 10x? A negative 5. Negative 5 times 2x makes negative 10x. Does negative 5 times negative 1 make a positive 5? Good. So we're good. All right, so I get to build my two sets of parentheses. What's going to go in one of them? 2x minus 1. Whatever you put here and here, you write one more time. And whatever's left over, which is the guy in the front and the guy in the middle, goes here. So x squared minus 5. And that's my answer, and I'm done. So this is everything. This is all the factoring we've been doing. Hopefully, it's getting to be easier. That's all. Smiley face.